This way everyone can come back to it at a later time. So the first thing we'll do is, as I mentioned, we're going to have an intro to Choregraphe, and then we'll build a box, and then we'll put everything together in an application later with some time for questions at the end. So first off, this is Choregraphe, what I have on my screen here. Let me just minimize my interface so hopefully you can see more on my screen now. So Choregraphe is, first of all, the NAO robot. What is that? On the right side of my screen you'll see a virtual NAO robot. If you don't have a robot, well, this is what it looks like. You probably already knew that. The robot has 25 degrees of freedom, and each controlled by a motor. It has microphones, cameras, ultrasound sensors, and tactile sensors, and it has more sensors for helping it walk, which are some force-sensitive resistors on the bottom of the feet and an inertial board. So those are used to help the robot walk, and all of the hardware is completely programmable. That's of course intentional. What Aldebaran strives to make is the hardware platform for software developers to do whatever you can think of with the robot. So with NAO, your imagination is kind of the limit. As I mentioned, every single piece of hardware can be completely manipulated by the human so that to make whatever application you can think of come to life. So before I get too much further, I do want to go and launch one of my first poll, which is, do you have a robot? I just want to get a feel for how many people have a robot and how many don't. Okay, about 10 more seconds of that, and then I'll close that poll. Great. All right, so it's kind of a 60-40 split with people who don't have a robot, people who do, which is interesting. I had expected a different layout, which is very, very good to know. So let me introduce you to Choregraphe. Again, once you buy the robot, once you have a robot, you have a copy of Choregraphe. Choregraphe is the graphical programming interface that we use to program the robot. Other interfaces are also available. For example, you can use one of our software development kits to program the robot in Python, Java, or C++. If you are not familiar with programming languages like that, or if you just don't want to use a programming language, you can also use Choregraphe to program the robot, and you'll see how Choregraphe gets you started really quickly and lets you go as far as you'd like to go. So that's why we have this product. So this is what it looks like, and these different panels that you see here, actually you only see one right now, but what's called the robot view here is a panel that's what I'm referring to as a panel. Everything is dockable. All of these different panels and more are available. So I can move this anywhere I want and, dock it however I'd like. So if you ever feel crammed in Choregraphe, well, just don't feel crammed. You can get rid of, resize anything you want. So for now, I'll just close this to kind of prove my point. Now I have this giant blank space. So this is the only thing you can't close. This is called the workspace. And on the left of it, I have a global start. I'm drawing an arc from the global start right now. On the right, I have the global stop. So I'm going to get two panels. One's called box libraries, and one is going to be called the robot view. So that's what I just closed. All right. In the box libraries panel, we have pre-made boxes that we can use to program the robot. Also, if you have opened up Choregraphe, well, actually two things. Choregraphe is available on the community site, so that's at community.aldebaranrobotics.com, and I'll put that in the chat as well in case you forget. Community.aldebaran.com. So that is a place where you can get a free account, and there you can download Choregraphe, and you can have a 90-day trial if you don't already have Choregraphe. So feel free to play around with it if you don't have it yet. So go to Community, make an account. That's also where, if you have a robot, that's also where you will find a lot of the documentation, all of the documentation, and there is a lot of it available if you have any questions or if there's anything, anything you're curious about. We have a very robust documentation. And then if you are in Choregraphe and you are not connected to a robot, and so that your robot view, you just don't have a robot connected, and you don't have at the top a message that says connected to a virtual robot, then you can just hit this green radio button on the top toolbar, and that is the Connect To toolbar. So, or Connect To button, so you can just click it, either connect to your robot, or I can connect to a virtual robot. Virtual robots are outlined in blue, so that's why I have watermelon.local, and watermelon is the name of my computer, so that's why this robot has that particular name. So I've already made the connection. I'm going to cancel this, but that's how you will bring up the connection to a virtual robot. Oftentimes, if I want to connect to a virtual robot, sometimes I have better results going into connection, the drop-down menu, and then I'll connect to a virtual robot from there. And if you have any problems connecting to NAO key, don't worry, it's not the end of the world. You can just close and restart Choregraphe, no problem at all. So this is the programming interface right here. We have in the top right, no, this is the left, the top left, we have the file new, open, save, some undo, redo buttons. The connection buttons I just introduced you to, the red one is to disconnect. And then once I build a diagram in my workspace here, I will be able to play it, stop it, and debug it. In the top right, these buttons apply to real robots, so if you're connected to a physical robot, you can wake it up, send it to rest, and turn on autonomous life. Robots come out of the box with the autonomous life feature. Autonomous life simulates human interaction by tracking human faces, listening for their voices, and localizing the voice. Therefore, once it localizes the voice, it'll turn its head to see the human. And finally, it'll listen on its tactile sensors for human input via touch. So the buttons on the top right are for controlling the robot's motors, which is what the wake up and rest is for, and for controlling the robot's behavior in some way by turning life on or off. So we're going to control the robot's behavior in other ways as well. The first thing that we will do is connect to SayBox. So the way Choregraphe works is very simple. In the folders on the box library, expand it so that you have audio expanded, and within that you have voice expanded, and then you'll see a SayBox there. So we can just click and drag the SayBox and drop it out in the space, in the workspace. It matters not where this SayBox is. It can be anywhere in this workspace. It only matters how the arcs are connected. So to do that, as I mentioned, in the workspace on the top left we have a global start. So I'll connect that to the input of the Say, and the SayBox has two inputs. I'm going to connect it to the matching one, the one that looks like a small play button. On the Say output, I'll connect that to the global stop, which is in the top right of the workspace area. So now, if you have your robot view you'll want to make sure you can see the space above the robot's head. That's where, so I'm saying that because I'm connected to a virtual robot. But that's where simulated text, simulated speech will appear. Oh, excuse me. All right, sorry, I had a message from the GoToWebinar. All right, so anyway, you'll right-click, or you can right-click in the robot view to rotate it around, and while your cursor is in the robot view, you can also zoom out. And I zoomed it out to about this height, if you can see that. That way I can be sure to see the text above the robot's head. So I'll click play. And I should see a simulated text above the robot's head. Okay, so you might have seen the hello. Sometimes it takes a little bit of there. Okay, so I just moved the view a little bit so I could see the hello better. I kind of had to switch it around some. Just by, again, right-clicking to turn the view of the robot and zooming in and out in the robot view. Okay, so if you look again, anyway, I'm seeing hello above the robot's head here. And that's simulating what the robot would say if it was real. If you are connected to a real robot, you'll be hearing the robot say hello out loud. If I want to edit what the robot is saying, I'll just double click on the say box. And when I do, I see more boxes, more arcs, which tells me that this is a flow diagram box, which I'll explain a little bit about later. And I also see at the top that I'm connected, or excuse me, that I'm viewing the say box, where before I only had this one box here called the root. Now I have another one called say. So this is kind of like a file system, except that it's a box system. And it tells me which box I'm currently in. So I can tell that I'm inside the say box right now. As a best practice, you want to build everything up on root. So in the localized text, I can change what the robot says. So instead of hello, I have it say hello world. And that's all I need to do. I can click back up to root, see my familiar diagram, and then I'll push play again. I'm not getting the, there we go, it says hello world. I'm having a little bit of trouble getting the robot text to appear the right way. Again, I just keep adjusting the view slightly if I'm having trouble with it. Cool, so we have the robot saying hello. Next thing we'll do is we'll add a motion to this. So I'm going to delete the arc that goes to the end. I'll just do that by dragging a box around it and then hitting delete on my keyboard. I could also delete it by just right-clicking on it and cutting it. So I want to add a motion in between say and the end of the behavior. So I'm going to go into the motions folder in my box libraries on the left. And I'm going to grab, so the folder is going to be motions and then an additional folder called animations. And from there, I'll grab the hello box. And if you notice, at the very bottom of my box libraries, I have a tooltip. The very bottom left of my screen, it says hello, and that this is a simple hello animation. It also tells me there is no speech in the box, meaning the robot does not say hello. It's just an animation with some changing LEDs. So I'll connect the output of my say box to the input of my hello box, and the output of my hello box to the global stop. And now I'll push play again. The robot says hello, and you can see my my virtual robot is waving. So that's what I wanted. That's what I expected. I want it to say hello and then wave. So cool. Now we have a little bit more interactive behavior. The next thing I might want to do is I want to see if I can change this a little bit. I have currently say and hello in series, but I want to see if I can connect them together in parallel. So I want to see if these two will happen at the same time. So I'll just move my boxes around slightly and change the arcs so that I have both being initialized by the global start, and both are terminating the behavior. So I'm going to change this a little bit, and I'll change the say box so that now we say just hi, just a casually friendly robot saying hi. I'll push play, and you can see in my robot view I had the hi bubble, and then the robot began to wave but did not finish the wave, and this is exactly what we told the robot to do. So if you watch my screen again, you can see, I'm actually not sure how well you can see it, but you'll see these green signal lines, like little signal animations on each arc. And so that will give us a clue as to what might have gone wrong. And so you can see that the say box ended right when the robot was in this configuration where its arm is kind of hanging there out in space. So the say box triggered the global stop, which of course globally stopped the behavior. So since the say box is shorter, that's how that happened. One way to change this is I could just change my diagram so that say no longer ends the program, because I happen to know that the say box is the shorter box. But what if I have Martin Luther King's I Have a Dream speech in the say box? In that case, then I would want the diagram to look like the opposite, where the shorter behavior in this hypothetical case, being hello, does not touch the global stop. But that's not really the point of programming. We want to build you could think of it as an artificial intelligence here. We want the robot to do both things no matter how long they are, and then terminate the behavior. Lucky for us, we have a box that will help us out with this problem. So I'm going to actually delete the output of say so that both boxes, the boxes being hello and say, are just kind of hanging there. They have no outputs. And the box that I'm looking for will be located in flow control. So I will expand that, and at the very bottom I have wait for signals. So I'm going to put the output of say and the output of hello together into the wait for signals box. The wait for signals box does exactly what we expect it to do. And then I'll put the output of the wait for signals box into the global stop. So now when I play this behavior again, I have the robot saying hi, completing the wave, and then my program is terminated. So that's exactly what I ideally want to happen. I want this behavior to be smart enough that I don't need to think about things. I don't need to remember that I need to go change something later. If I change something, everything should be fine. And so you will be able to accomplish most of what you want to accomplish just by using the flow control items. So we have a counter, which is like a for loop. We have an if, which compares two values. We have an only once, which does exactly what it sounds like. And we have a switch case, which helps us filter. Usually we filter a response for different different inputs. All right, so that's a brief intro to the flow control folder, and that's a very useful place to look for solutions to your programming or logic problems. In Choregraphe, what we have three different types of boxes. We have we have four different types of boxes, and we have seen three of them so far. So let me go into them just briefly, and then we'll move on building our script box. So the first type of box in Choregraphe is called a flow diagram box. If I double click on the say, right where the mouth is, then I have more boxes and more arcs, and that means that I have a flow diagram box. So again, another box, and items tied together like this. This is called a flow diagram box, and that's what the say box is. Again, I have this box hierarchy up top that lets me know that I'm inside the say box. Be careful when you're building programs. You don't want to, build stuff inside the say box unless you really intend to. As a best practice, you'll keep everything on the root level. The second type of box is called a timeline box, and if I double click on the hello box, this is what a timeline box looks like on the inside. On the top left, I have the word timeline, which is how I can tell I'm in a timeline box. And the timeline layer contains a motion layer and behavior layers. So the motion layer, those gray boxes are joint positions for different places in time. Time is the small numbers at the top measured in frames. And so you'll have a certain number of frames per second. So these are the actual joint values that are controlling the robot. When we make the wave, so we have joint values for the right arm, the whole right arm, and for the head, because the head moves a little bit when the wave happens. And then we have behavior layers here. Again, I'll click back to root to go up top. And the third type of box is a wait for signals box. So I'll double click on that. And when I do, I get a script editor. Again, this might be docked somewhere uncomfortable in your screen. If it is, just undock it, resize it, and move on with your life. Okay, so the script editor looks like this. And so the script box is driven by Python code. And this is a typical example of it. The wait for signals box creates a for loop and then waits for both values of an array to be true. And when that happens, then we get a output on stopped. So this is what a typical script box will look like. And that's the third type of box. So the fourth type of box is called a dialog box. And I won't cover it, but dialog boxes are a way that we can create robust / long or large dialogues or conversations with the robot, and we can do it in just one box. And we use a syntax called keychat to do that, which is based on JavaScript. So we have, again, flow diagram boxes, which is what the say is, timeline boxes, which is what the hello is, script boxes, wait for signals, and dialog boxes. So what we're going to do is we're going to build our own script box. So if you want to, you can save this behavior, just the icon on the top left says Save Project. So this is a good time to do that. I'm going to clear the screen and start with a script box. So I'm going to highlight everything and hit delete. I'm just going to drag a box around it, and it's highlighted when it's blue. And to build my own box, all I need to do is right-click in the flow diagram area in the workspace. I get a menu item to create a new box, and then I'll just choose Python, which is what they're calling a script box. I called it a script box, they call it Python here. I'm going to name my box and provide a description. I encourage you to be very verbose whenever you create a description or a name for the box, because you never know who's going to use it later, the box. And it's better to know too much about it than to not know enough about it. So here I'm going to name this wait 5 seconds. I'm going to call it wait 5S, S for seconds. Because that's what we're going to do when we build our Python box. We're going to use a pretty basic Python function, and we're just going to have this box be kind of a timer. Alright, so the description is, after receiving an input, this box waits 5 seconds to stimulate an output. I have more adjustments I could make at the bottom with the inputs, outputs, and parameters field, but I'm going to leave that the way it is for now. We don't really need anything special for this box. So I'll click OK, and now I have this box. If I hover over it, I get my tooltip that I just built, which will help any future users or myself if I forgot what I did in this box. Okay, so to edit this box, I'll just double click on it like we did for the wait for signals, and then up comes the script editor. So this is what a typical Python box looks like. This is all the kind of default. This is what a default box looks like. What we have here, the first 3 lines, again you can see the line numbers to the left of the text here. We have lines 1 through 20. So the first 3 lines are typical Python for generating a class. So essentially every box is its own class, and we use the Python constructor init, and this is just typical Python, what we would do if we generated a class. Beginning on line 5, 9, 13, and 17 all contain event handlers, which do what they sound like. When an event happens, then we have some kind of response for it. So for example, on line 5 we have we've defined the onload function, and on line 7 the function, that is, you could think of it as the reaction that will happen when the box is loaded, is that we will pass, and that's a Python function for just moving on to the next thing. So all of these are essentially empty so far, except for the onStop, on which we unload we unload and stop the box. Okay, so what we want to do, let me just show you real quick what we're kind of dealing with here. Let me close this box. So the wait for 5 seconds box has 2 inputs. We have an onStart. I'm just getting that information by hovering over the input or output that I have a question about. And then we have an onStop. So whenever we usually receive an input, we receive it on the onStart, and then we eventually trigger the onStopped, which ends in a D as in dog, past tense. So this small X on the wait 5 seconds is called the onStop, ending as a P, ending in a P, and the onStopped on the right ends in a D. So they're 2 different variables, and Just kind of remember that. All right, so what we want to do is when we get a signal here on the onStart, then we'll wait for 5 seconds and then trigger the output. That's all we want to do in this box. So we can edit it like this. We'll go to the onStart input because that's what we're waiting for. When we get a signal on the onStart, then we do something. So here's where we put the actual task, which is going to be to sleep for 5 seconds. So this is a Python function, sleep, in a Python module called time. So time with function sleep takes an argument of 5 in this case, but it takes an argument that is a number in seconds. Excuse me. Alright, next thing we want to do is we want to just say once you've slept for 5 seconds, then we will trigger the onStopped output. So this self.onStopped is a function you can use in your boxes. There are a number of these functions: onStopped, onload, onload, get parameter, and there's more. These are box functions that Aldebaran has made, and they're available for your use. So this is where the onStopped comes from. So basically all this says is you get an input onStart. Remember, onStart is the name of the small triangle input. Then you sleep for 5 seconds, and then you send a signal on the onStopped output. And that's it. That's all we have to do to make this box sleep. If you haven't worked with Python before, you need to know that it is highly dependent on indentation. So where I've put the T and the S right here are very important. I have them 4 spaces indented from the function. So where you have def, I just go, in line with def, and then 1, 2, 3, 4 to the right. So Python is kind of all about the indentation. So that's very important, and syntax is important as well. So try to make your box look like mine. Okay, so I don't have to save this before I close it. I'm done editing this. So I can just close this. And to test this box, I can just draw arcs to the input and the output. And I'll know if I'm successful if I end up with the play button illuminated. If I'm unsuccessful, then the global the global stop will never be triggered, so the behavior will still be running. So that's how this test works. So I'll just hit play. I saw the green signal going from the output of my wait to the global stop, and I ended up being able to hit play again. Another way I could test this is I could just put a say box, out here, and then I could edit this to say success out loud. I like to do that sometimes when I'm working with a robot. And the say box is an easy way to debug. So I can do like this, and as long as my display is fine, I can see that the robot the signal successfully exited the wait for 5 seconds box. So my say box is, so my wait box is fine. If your box turned red, that's no big deal. It just means you have some syntax errors in your box. And if you need to, to begin debugging the box, a log will pop up. Usually it pops up right in the bottom of the workspace. And so it usually is there automatically. It tells you where the error is, and then you can just double-click in your script box to edit it. So one thing that is common is, again, the indentation, and then we have a capital S here in onStopped, So that is important. So spelling that is correctly is important. Okay. So what I'm going to do is, if you want to, you can save this box in your own box library so that you can use it later. I won't go into how to do that exactly. If you want more details, you can check them out on our documentation. This is well documented. So I'm going to save this to my box library, and now that box is available for me. I can take it out as many times as I want. Okay, so now we have that. Next thing that we'll do is we'll build a short application, and we'll use our new box in the application. So I'm going to clear my screen. If you want to save your project so that you have this box later, or you want to save your box to your box library, now's a good time. So I'll clear my screen. And I will look at what I might want to do with my application. What kind of application do I want to build? Let me just check if I have any questions so far. And looks like no questions. Okay. So next. Alright, let me get rid of this. Alright, let's build an application. So the beauty of using a NAO robot is that it's a humanoid robot, and really the whole point, as I mentioned, is for creating these moments in people's lives. So designing a moment that, everyone, that people, a moment that really impacts someone or really sticks with them when they say, wow, I really felt like that robot was talking to me specifically. I really felt like I had a connection with that robot. Those are the moments we want to design. And that's the beauty of working with a humanoid platform like we have. So what I'll do now is this might not be one of those moments that stick with people forever, but it will be a kind of a cute moment. So we'll just have the robot say something like, how are you doing, to the human, and then the human is just going to touch the robot. So I'll put a say box. I'll get that first. And I'll edit it so that I have the robot saying, how are you? And then I'm going to have the robot listen for touches on 2 of its sensors. As I mentioned, the robot has tactile sensors. The tactile sensors are on the hands, feet, and head. So for this example, I'm going to get the boxes that listen to the head and to the feet. Those boxes are in a folder called Sensing. So I'll grab the tactile head box, which has an icon of the robot's head, and I'll grab a bumpers box, which, if you look closely, it highlights the right and left foot of the robot in the image. Okay, so if you're looking at the robot, or if you don't have one in front of you, the bumpers are the red kind of band on the foot, and the tactile head sensor is right on the top of the head, and it doesn't really display in the robot view, but trust me, that's where they are. So that's just so you know, if you weren't familiar with it. Okay, so we'll have, the robot just says, hey, what's up? And then we have the human is going to touch the robot in one of 2 places. So if the human touches the foot, we'll just have the robot say, hey, that tickles. And you see how I connected the bottom 2 outputs of the bumpers box? I know that those are the outputs that I want because I can hover over those outputs, and the tooltip tells me that the bottom output is when the right bumper is stimulated, the middle output is when the left bumper is stimulated, and the top output only tells me when the box has stopped listening. So I'm not interested in that output right now. Big tip, hover over all the inputs and outputs if you ever have a question. So the robot's response to someone touching the feet is going to be, the robot says, "That tickles." And then the robot's response to someone touching its head will have the robot, I'm going to have it do a custom animation that I built. Again, the same way that we built our wait for 5 seconds box, we can build animations. So I'll have the robot first do a bow. By the way, the tactile head has 3 outputs because the robot has 3 tactile sensors on the head. So if I hover again, I have front, middle, and then rear. So that's normal. Okay, so I'll have the robot bow, and then at the same time, I'll have the robot wait for 5 seconds. So in a parallel action here, I'll have the robot waiting, and when it's done waiting, I'll have the robot say, something clever. I'm not totally sure what's a clever thing to say here. "At your service." Maybe that's clever, maybe not. Not sure. Okay. Alright, so when I play this, again, kind of got to try to get the robot in a position I can see the caption. "How are you doing?" Now, I'm using a virtual robot. You might be wondering how I intend to touch the robot's head, since this robot is entirely inside my computer. All I need to do is double-click on the output that I want to pretend to stimulate. So I'll double-click on the bumper's output. I double-clicked, and I did see the robot, or excuse me, I saw the say box complete, although the text didn't properly appear. Nothing to worry about. I know it's okay because I saw the say box complete. And I'll pretend like I touched the head. Have the robot bow, and then say, "At your service," which is what I want it to say. I'll stimulate the foot again. The robot says, "That tickles." And stimulate the bow by clicking any of the tactile head outputs. That's why I chose all 3. Cool. So the robot is doing the 2 things, the 2 different reactions the way I expected it to. So anyway, this is just a brief kind of what you could do with the boxes that you build. For example, I have built the bow box and I built the wait for 5 seconds box. So again, with the hardware is the only constraint. Once you're familiar with how you can manipulate different pieces of the hardware, then the sky's the limit. And if you need something more heavy duty, I've hopefully demonstrated that you can add whatever you need in a Python box, for example. You can even add it in a timeline box by building your own animation. So by building your own custom boxes, then Choregraphe becomes even more powerful than it starts out as. So now I'm going to stop talking, and I'll look for some questions. So if you have any questions, now is the time, and I'll leave it at that until I hear from some people. Oh, actually, while I wait for questions, if you don't have a question, I'll send another poll out, which just asks if you would like to attend, or if you would be interested in any of these type of webinars again. Alright, I'll give it 5 more seconds and close it. Okay. Cool. 100% yes. Alright, I'll wait for some questions. All right, I got a statement from Preston. Thank you, Preston. Merry Christmas to you, too. Last time I got questions from the audience, and they were wondering about if I was going to cover any timeline boxes. And so I didn't plan on doing any timeline boxes, but that might be something I would do a different webinar in if you have questions on how to put that together. So Janice asked, how would you create a program for the NAO to walk in a circle? That one should be pretty straightforward. So we didn't cover this in the webinar, but we have boxes to make the robot walk. So I will clear my screen, save this if you want to save it, and then I'm going to delete it. Standard. All right, so to make the robot walk, we have a folder called Motions, and we have the Move To and the Move Toward box. I'll explain the difference is explained, I think it's explained in the documentation, but for this I'm going to take the Move To box, and I'll edit the parameters of the box by clicking on the wrench. And I can make the robot walk in a circle a number of ways. I could have it, what I'm going to do is actually I'm going to have it go 0 meters in the X, 0 meters in the Y, but I'm going to have it go 6 point, oh wow, I can go pretty high. I want it to go well, I want it to make a full circle, which is either 360 degrees or 6.28 radians. But this unit is actually in degrees, which is actually a change from the last version. So I'll just type in 360 degrees. I think it actually is in radians. All right, so I'm going to go with 6.28. Okay. And when I connect this, you'll see my virtual robot. Usually for the walk of the virtual robot, sometimes it falls down in the beginning. That's just kind of normal. So the robot, I got an error. Alright, let's increase this in case we're not getting what we want. Alright, so the maximum rotation I can have here is 180 degrees. So I guess what I would do here is I'd probably just put 2 of these together. So for the first one I have the robot rotating 180 degrees. Second one it rotates 180 degrees. Altogether it's 360. The robot view always updates so that this horizontal line is always in line with the robot itself. So it kind of, in a way, doesn't look like the robot's moving when we do this, but it is. It's just the way the display is going. Alright, so there we have the robot going 360 degrees. So that's a pretty small circle. If I wanted it to go in a larger circle, I could have it, rotate. I could give it coordinates in the x direction, so it ends up out here somewhere, rotated by, 90 degrees, and then I could put 4 of those boxes together, so it ends up kind of rotating like that. Alright, so I got another question about languages from Preston. So that's a pretty fast one, so I'll answer that one. The question is, my virtual now does not translate when I type hello world in a different language. It continues to say hello world in English. So that's not a big surprise. I will replicate what's going on there. So if I grab the say box, I'll go inside the say box, and typically installed languages are in bold. It kind of appears that these are all in bold, but I'm actually not sure how it works with the virtual robot in the language. But I will go to Spanish. I'll change to Spanish. And where my box before it said hello, now it says hola. But this has not been translated. This is just the default word that's in this box. So the same way we did not type hello in the English box, that's why this hola is appearing here in Spanish. So if I want the robot to say something in Spanish, I need to type it in Spanish. So, buenos días. Hola, buenos días. That's all I'm going to venture to say in Spanish. Okay, so now this is a say box that is written in Spanish. If I go to root, the other thing I need to do is set my language to Spanish. Usually a robot will have 2 languages available here. Okay, so once that's complete, once the robot's language is set, then we can just click the play button there. Alright. And now the robot says, hola, buenos días. So it doesn't the answer to that doesn't translate Spanish for you. It just will say whatever Spanish you type. Alright. Alright, so if we don't have any more questions, then you'll be able to view this this webinar. When we're done, it'll be archived, so you can come back to it. And then if you have any questions, you can visit the community site, or if you want to talk to someone, at Aldebaran, you can email me and I will put you in touch. So thank you everyone for attending, and have a fantastic rest of your Monday.